Displaying of descriptive statistics. So it is important that we learn how to summarize tables, charts, and graphs. And the main focus in this lecture is basically to help us focus on descriptive statistics, how to summarize and present data, and also to demonstrate various techniques that are available in displaying what we call descriptive statistics. So we, in this case, are going to look at the various tools that will be useful for data display, like histograms, like bar charts, the pie charts, and also the line graphs. So we should also learn how to come up with what is called a frequency distribution table. A frequency distribution table. Now, what is a frequency distribution table? And how do we use a frequency distribution table? So we'll be given data like this, where we are asked to show the daily demand for hammers in a store for 20 days. So in the frequency distribution table, we're going to now itemize the number that we have here. We have the smallest number being a 0. We also have a 1. We also have a 2, a 0, a 1, a 2, a 3, and a 4. So these are our variables x. So how many zeros do we have? We have 1, 2, 3, 4. So if you want, you can even use a tally here. There are 4 zeros, 1, 2, 3, 4. The ones have 1, 2. So the tally is 1, 2. So the frequency is 2. How many threes do we have? Threes we have 1, 2, 3, 4. Threes we have 4. 1, 2, 3, 4. Let's skip the 2. The twos we have 1, 2, 3, 4, 5, 6, 7. So the twos we have 1, 2, 3, 4, 5. We've drawn like that. 6, 7. We have 7 twos. And finally, the fours, we have 1, 2, and 3. So we have 3 fours. 1, 2, 3. So this is in a tally form. So the frequency divided by f. So we can have what we call the relative frequency, simply dividing the frequency over the total. So 4 divided by 20 is 0.2. 2 divided by 20 is 0.1. 7 divided by 20 is 0.35. 4 divided by 20 is 0.4. 0.2. 3 divided by 20 is 0.15. Then you can also have what we call the cumulative frequency, simply adding up. The 4, we can add up what? The 2. So 4 plus 2, we get a 6. The 6, we add the 7, what do we get? 13. To the 13, we add the 4, we get what? 17. And to the 17, we add a 3, we get a what? A 20. So this number and that number should always tally. So this is how we come up with the cumulative frequency column. We could as well come up with what we call the relative cumulative frequency by using the relative frequency. So the 0.2, you put it here, right? Then you add 0.1 there will give us 0.3. The way we're doing it, then you add the 0.35, we get 0.65. Then we add the 0.2, we get 0.85. Then we add the 0.15 to get 1.00. So when you total up here as well, 1.00 should be the same as the last number on the relative cumulative frequency. That is how we come up with the frequency distribution table. Let's try another one together. Let's try another one together. So if you're given data as follows, and you're asked to come up with cumulative frequency. Do you remember how do we come up with the cumulative frequency?
You add the frequencies.
Okay, so we have a 4, then what happens? 4, next, what do we have? 4 plus 8, we get what? 12, then to the 12, what do we add? So we have a class. We have 1 to 5, 6 to 10, 11 to 15, and 16 to 20. So in this case, we are given the frequencies for 8, 6, 2. So we said firstly we total up. This is 20. So the 20, if we're getting the cumulative frequency, we said we add up. So what do you say we do?
We're supposed to add the frequencies. So the first one will be 4, since we're not adding it to anything.
Mm-hmm.
Then we'll have 12.
Mm-hmm.
Then we'll have 18, then 20.
Good. Then how do we find the relative frequency and the relative cumulative
I
frequency?
wasn't there when.
So we are dividing. So 20 into 4. What do we get? 0.2.
5. Oh, 20 into 4. That's
Then 18 divided by 20, 0.4. Then 6 divided by 20, 0.3. Then 2 divided by 20, 0.1. When we add up, the total will give you a 1.
So must it always be 1? The
Yeah.
relative frequency should always total 1?
Total 1, yes, or 100%, yes.
Oh, okay.
Then the relative cumulative frequency, the same thing, 0.2, we add 0.4, get 0.6, add 0.3, 0.9, add 0.1, we get 1.0. So these two must be the same to correlate. Are we together?
Yes, we are.
All right. So this also brings us to another part of finding the midpoint. The midpoint is simply when you add the lower bound plus the upper bound divided by 2. 1 plus 5 is 6 divided by 2. What do we get? 3.
3.
Okay. So the distance from here to here to here to here, or distance from here to here to here is called the height. So height is 5. So this height is important. You can,
Okay.
once you find the answer, you just keep adding the height. So 3 plus 5, 8. 8 plus 5, 13. But if you forget that, just continue what you're doing. 6 plus 10 is what? 16 divided by 2, 18. 11 plus 15, 26 divided by 2, 18. 16 plus 20 is 36 divided by 2, 18. That is how we find midpoint. Is that clear?
Yes, it is.
Okay. Then we go to our f of x and f of x squared. So we simply multiply the f column and the x.
Yes.
Okay, so we calculate where is our f of x, so column f times column x. What are we getting?
F is 12.
Okay, so what do we get?
Our first f of x is going to be 12.
So 5 times 4 is 12. 8 times
Then we're going to have
64.
we're going to have 64.
6 times
Then
13.
we're going to have 6 times 13. We're going to have 78.
2 times 18.
36.
Then when you total up, we're going to get the f of x. So 12 plus 64 plus 78 plus 36. You get
22.
190, isn't it? 12 plus 64 plus 78 plus 36 is 190. Okay, then we're going to square the values of x here. So x squared is 9. 8 squared, 64. 13 squared, 169. And then 6 squared, 1296. So now we're going to start again. Apply the frequency times x squared. So 4 times 9, 36. 8 times 64, 512.
Hi, Colin.
Yes, please.
I'm a bit confused on the last figure that you have found there.
This one, 190.
No, 1,296. Isn't it supposed to be 324?
Oh, sorry. Let me do it again. 18 squared, N squared is supposed to be 324, yes. 324. Thanks for the correction. Yeah. 324. Then we multiply now. 6 times 169. 10, 14. 2 times 324. 6, 48. Then we add 10, 14 plus 5, 12 plus 36. So we get summation of fx squared, which is 22, 10. Okay. So we have what we call the frequency distribution table. We need to find 3 things from here. We need to find 3 things from here. Number 1, we need to find our mean. The mean is x bar, summation of f of x divided by our n. The n is the frequency, the total frequency is what our n. So what is our summation of f of x? 190 divided by our n, which is 20. So what do we get here? 190 over 20, we get 9.5. Okay. So we also got what we call the variance. It's given by summation of f of x squared minus summation of f of x to the power 2 over n, everything over n minus 1. So here we're going to have 2210. That is our f of x squared. Minus summation of f, which we already have as 190, power 2 divided by n. N is 20. Everything over 20 minus 1. So you start from here. What is 190 squared over 20? 190 squared over 20 is 1805.
Collins, I'm sorry for asking too many questions.
No problem.
Why are you leaving out the negative?
Wait, which negative is that?
This minus here.
This one.
No. On the on the minus 190. If at all we are starting with it, why aren't we including it? So it's going to be minus 190 squared. Oh, okay, I get it. It's still going to give us a positive. All right, thank you.
No, the negative here, we leave it here. We're just squaring this number there. So 190 squared over 20 is 1805. So we will do 2210
Oh,
minus,
all right.
yes,
Thank you.
the top part will give us 405. The bottom guard will give us 20 minus 1 with what? 19. So our variance is therefore equal to 21.316. 21.316. That is how we find our variance. So the variance, when you square root it, we get the standard deviation. So standard deviation is the square root of the variance. So in this case, we found 21 0.315. We square root it. We're going to get 4.617. This is called the standard deviation. And we also have what we call the coefficient of variation, which is simply the standard deviation over the mean times 100. So our standard deviation, we've just calculated it as 4.167, and the mean we found as what? 9.5. By this by 100, we get 48.59%. So let's go through what we did to wrap up. So we initially just given these two columns here. We want to get our 15 marks. Come up with the frequency distribution table. How do you find the cumulative frequency you add on? 4 plus 8, 12, plus 6, 18, plus 2, 20. Are we clear on the frequency, cumulative frequency? Then the relative, we're just
Yes, we are.
4 divided by 20 is 0.2, 8 divided by 20 is 0.4, 6 divided by 20, and 2 divided by 20. This is how we found the figures here. Then relative cumulative frequency, we add on the we've been adding. 0.2, bring it here. We add 0.4, we get 0.6. We add 0.3, we get 0.9. We add 0.1, we get 1.0. Okay. Then we went to finding the value of x, the midpoint, by adding the lower bound plus the upper bound divided by 2. So 1 plus 5 is 6 divided by 2, 3. 6 plus 10, 16 divided by 2, we get 8. 11 plus 15 divided by 2, 13. 16 plus 20 divided by 2, 18. Then to get the f of x, we multiply, this is our column 1, and this is our column 2. And to get our column 3, so it's column 1 times column 2. So 4 times 3, 12. 8 times 8, 64. 6 times 13, 78. And 2 times 18, 36. And in total up, we get what we call this summation of x, which is 190. And our summation of f is the same as n. When divide 190 divided by 20, what we get is called the mean. The symbol for the mean is x bar. Are we together so far?
Yes, we are.
Then we went to now square the values of x here. 3 squared is 9, 8 squared 64, 13 squared 169, 18 squared 324. Then multiply by the frequency, so 4 times 9. So the mistake people make, they want to square these to get the answer. Don't square this. You start again, column 1 times column what? 3. Column 1 times column 3, afresh. Individually, 4 times 9, 36, 8 times 64, 512, 6 times 169, and 2 times 324. The answers there, you add them up. That is a summation of fx power 2. Are we together?
Yes.
So to go to get the variance, sample variance is summation of fx squared minus summation of f to the power 2 over n minus 1. So start with the big figure here, 2210 minus 190 squared over 20 over 20 minus 1. So 190 squared over 20 is 1805. 1805 from 2210 is 405. 20 minus 1 is 19. 19 into 405 is 21.36. So that's how we find the variance. The relationship between the variance and the standard deviation is that when we square root the variance, it is now called the standard deviation. So square root of 21.315 is 4.617. Then divide this by the mean of 9.5. We get the percentage, which is 48.60. This is our coefficient of variation. That is how we use our grouped data. We can also do the same for ungrouped data. If we have 2, 4, 6, 8. Okay. You can square them. When we add this plus that, we get 6. 6 plus 6, 12. 12 plus 8 is what? 20. So that is our summation of x to 20. Then we square them individually. Here we get 4. 4 times 4, 16. 6 times 6, 36. And 8 times 8, 64. Data comes. Okay, so this is how it's done. Are we following so far?
Yes, we are.
So total this part for me, the x squared.
It will give us a 120.
So we're going to get 120, summation of x squared, 120. Then our n is the number of respondents. How many sample respondents we have? How many data sets we have here? They're actually 4. So the 4 data sets.
Sorry, my network is breaking, Collins. Just repeat yourself after we did the summations.
So the summation here, then the n, how many data sets observations we have there? 1, 2, 3, 4. So there are 4 observations.
Oh,
So I want you to find the mean. I want you to find the variance. And I want you to find the standard deviation. The formulas are all here. Quickly use your calculators and the standard deviation. But this is one group data. We've done almost everything. I've given you the formulas and the coefficient of variation. So just on the same data set that I've given you. All right, and try that.
okay. The mean will be 5.
How did you get it?
20 minus divide by 4, which is going to be 5.
Good. And the variance?
Unfortunately, I have left my calculator. I'm back in the office, so.
Okay, so I just need you to give me the narration of what to put.
Okay, so our EX squared is going to be 120 minus EX squared, which is 120 over 4.
So
And
these are different things. So the EX all squared is a 20 to the power 2. So this is a mistake students make.
oh, okay, so it's going to be the 20.
You get it, huh?
Yes, I do.
So you need to differentiate that. So the final answer you're going to get is a 40. So how do we get the standard deviation?
The standard deviation is going to be, sorry, Collins, I'm confused.
The square root of the answer. Standard deviation is square root of the variance. So since we found 40, standard deviation
okay.
Square root of 40. 6.324.
Okay.
In the coefficient of variation, we simply divide our Standard deviation,
standard deviation over
the mean,
Uh.
right? It's 100.
100.
Okay. So you're going to get 126%. Right. So basically, that is our data presentation session. I'll send you homework which I need by Sunday, just based on what we've covered previous two sessions, Unit 1 and Unit 2, data presentation, group and ungroup data, and also yesterday's session, data collection, sampling designs, reasons why we sample. So if you didn't attend yesterday's class, please watch the video. So I'll send you 20 questions. The pass mark is 10 out of 20. Actually, 15 out of 20.
Yep.
I will
All right.
diligent want you to look at that. So have a great day. Enjoy your
All right. And please send the homework on time.
All right, I'll send it.
All right.